You know, it's kind of wild when you think about it. This thing in your pocket, right? How did it go from just being a phone for making calls to, well, to being everything? It wasn't magic. It was this incredible journey, this quest really by some super smart people solving one problem at a time. So, let's get into it. Let's uncover the secret history of how your phone learned to go online.
All right, here's the game plan. We're going to start way back from Marconi and car phones. Then we'll look at how they first tried to cram data onto voice calls. After that, the big one, the always-on packet revolution. We'll dive into a huge digital divide, see how a technology called CDMA rose to the top, and finally connect all of that to the packet-powered world we live in today. It's going to be quite a ride.
Okay, let's kick things off with Section 1, from Marconi to car phones. And yeah, our story starts way before the internet was even a twinkle in someone's eye. It all begins with a really basic idea, wanting to talk to people without being chained to a wall by a cord.
And wow, look at this. This journey took forever. I mean, from Hertz first demonstrating radio waves in 1880, all the way to the first commercial cell system lighting up in Chicago in 1983, that's over 100 years. And here's the most important thing to get from all this. Every single piece of this, from the cop car radios to those giant brick phones, was built for one thing and one thing only: your voice. Data? Nobody was even thinking about data. It wasn't part of the equation at all.
All right, so that brings us to our next chapter, giving voice calls data. Because now we've got a problem. The internet is starting to become a thing, and engineers are scratching their heads, trying to figure out how in the world to get that onto these brand new mobile networks.
And yeah, that was the big question, right? How do you send data, websites, emails, all that stuff, over a network that was really at its core just a super fancy system of walkie-talkies? The first answer wasn't a revolution. It was more like a really smart hack.
It was called HSCSD, high-speed circuit-switched data. Don't worry about the name. Just think of it as a bridge technology. It didn't tear everything down and start over. Nope. It just cleverly tweaked the system we already had. It was like going to the network and saying, hey, you know that one little lane you give someone for a voice call? What if, and hear me out, what if we bundled a few of those lanes together and made a bigger pipe just for data?
And it worked in two pretty simple ways. First, just like we said, it combined a bunch of voice channels. So instead of one tiny pipe, you got a much fatter one. And second, it got smarter. It realized, hey, if the connection is really good, I don't need to waste so much time checking for errors. And by doing less error correction, it freed up more space to cram in more data. We're talking a jump from 9.6 kilobits per second up to 14.4 per channel. It was a fantastic first step, but it was still a patch. It was a workaround. What we really needed was a revolution.
And that brings us to Section 3, the always-on packet revolution. And I gotta tell you, this wasn't just another small step. This was a giant leap. This was a complete change in how we thought about mobile data, and it's the reason your phone works the way it does today.
Okay, this slide explains everything. The old way, circuit switching, is like having your own private highway. For your entire call or your entire data session, that road is reserved just for you. Even if you're not sending anything, just sitting there idle, you're still paying for the whole road. Super inefficient. Now the new way, packet switching, is completely different. It's like the Postal Service. Your data gets chopped up into tiny little packets or packages. They all get thrown into the mail system with everyone else's packages. They travel together, and then they're put back in the right order at the destination. It's a shared system. It's brilliant. It's efficient.
And this new way of thinking was called GPRS. And it was a total breakthrough. I mean, think about what this meant for you, the user. Your phone was suddenly always on. No more of that horrible dial-up screeching sound. No more waiting to connect. You just were connected. And you started paying for the data you used, not the minutes you were online. This was huge. Plus, under the hood, it built the foundation that 3G would be built on. This right here was the real birth of the mobile internet as we know it.
So things are looking good, right? But just as this packet switching idea is taking off, a massive fight breaks out, a huge conflict. We're talking about a standards war, especially in North America, between two totally different ways of building a digital network.
In one corner, you had TDMA, and the polite conversation analogy is perfect. Imagine you're in a room, and to keep things orderly, everyone gets a specific time slot to talk. Okay, you go, then you go, then you go. It's neat, it's organized, but you can probably guess that you can't fit a whole lot of people in that conversation before it gets bogged down. And in the other corner, you had CDMA. And this idea was kind of mind-blowing. Forget taking turns.
With CDMA, it's like a huge party where everybody talks at the same time on the exact same frequency. The trick? Everyone's speaking a different language. Your phone is programmed to only understand its specific language or its unique code. Everything else just fades into the background like a low hum. It's a wild concept.
And when you put them side by side, you can see why this was such a war. CDMA was a totally different beast. Look at the capacity. It could handle 8 to 10 times more people than the old analog systems, versus just 3 times for TDMA. And then there's handoffs. With TDMA, when you drove from one cell tower to the next, it was a hard handoff. It would drop the connection to the first tower before picking up the second one. That's why calls used to drop all the time. CDMA did a soft handoff. It would connect to the new tower first and then let go of the old one. Brilliant. No more dropped calls. On top of that, it was more secure and was built for data from day one. It was just better.
So, let's move on to Section 5, the rise of CDMA. Because with all those advantages, it's probably no surprise who won this war. The industry started to line up behind CDMA, and that's what really opened the floodgates for high-speed mobile internet.
And you can see the family tree right here. It all started with CDMA1 back in '95. That evolved into its kid, CDMA 2000, which was a huge step up for both voice and data. But then came the real superstar of the family, EVDO. You can think of EVDO as a dedicated, super-fast data highway that was built right on top of the existing network. Its one and only job was to deliver data, fast.
And just look at this jump. It's insane. We went from a sluggish 14.4 kilobits per second with the first generation to 144 kilobits with the next, and then, with EVDO, a massive leap to 3,100 kilobits per second. That's 3.1 megabits. We're talking about a speed increase of over 200 times. This is the moment when you could actually start watching a video on your phone or browse a real website, not some stripped-down mobile version. This changed everything. Okay, so let's bring it all home. Section 6, today's packet-powered world. How did all this history, all these acronyms, lead to the crazy fast 4G and 5G in our hands today? Well, simply put, everything we just talked about, it wrote the playbook. So here's the bottom line. The big ideas from GPRS and CDMA, they're the DNA of our modern mobile world. That whole packet switching thing, that's the foundation of 4G and 5G. The hardware, the actual boxes in the network, literally evolved from the stuff they invented for GPRS. The expectation that your phone should be always on and that you pay for data, not time, that started here. These early breakthroughs didn't just influence our world, they built it.
So you see the pattern, right? From that first clever hack of bundling voice channels to the wild idea of a multilingual party in the airwaves, every generation of technology solved the biggest problem of its time. Back then, the enemies were dropped calls and a lack of spectrum. They conquered them. So it really makes you think, what are today's impossible problems? We're heading into a world of real-time AI, VR, AR, a zillion connected devices. The fight isn't just about speed anymore. It's about eliminating lag entirely, about connecting everything, everywhere, all at once. What's the next CDMA? What's the next brilliant, mind-bending idea that today's engineers are cooking up for us right now?